Good morning, students. Today class we are going to discuss about a problem based on potential. So the question is, they given some charges. If charges 4 nanocoulombs, 3 nanocoulombs and minus 6 nanocoulombs are placed at the vertices of a square such that the calculate the charge that should be placed, so that what we have to get, the net potential at the center should be 0. Okay, so let us take what they given. According to that, we have considered a square and represent the vertices as A, B, C and D. Let us place the charges at A as 4 nanocoulombs, B as 3 nanocoulombs and C as minus 6 nanocoulombs. So we have to assume that the charge that is placed at QD is Q. Now what they are asking, to make potential at center, 0 at center. So draw the intersection of two diagonals. So at this point the potential should be 0. Let us assume the distance between these two is r and this also r. Then what is this? R by root 2. So from that what you can write? OA equals to OB equals to OC equals to OD, that equals to R by root 2. Now let us calculate potential at the center. VO is equals to what? VA plus VB plus VC plus VD. Okay, now what is VA? We can take as 1 by 4 pi epsilon naught QA by OA plus QB by OB plus QC by OC plus QD by OD. So what is the net potential at 0? O is 0. So send that side. What do you get? 0 equals to, since distance is common, what is that? R by root 2. What are the charges at A, B and C? 4 into 10 raised to minus 9 plus 3 into 10 raised to minus 9 minus 6 into 10 raised to minus 9 plus Q. So this if sent there, what you get? 0. The net charge is what? Q plus 1 into 10 raised to minus 9 equals to 0. That implies Q is equals to minus 1 into 10 raised to minus 9 coulombs. So this is the question that has been once for PU board exam for 5 mark questions. So you should make the potential at center should be 0, so that the net, simple, if you want to calculate in commutative point of view, what you can do is the net charge should be 0. If you make net charge is 0, potential also 0. But for 5 mark question we have to extend the problem by writing all the criteria what they have given. Is it clear? Yes. And the next question is, two charges are there, plus 1 nanocoulomb and minus 1 nanocoulomb are separated by distance. Calculate the potential at P, distance of 20 centimeters from center. The distance between them is 2 centimeters. So there are two charges, plus 1 nanocoulomb and minus 1 nanocoulomb. This is A and this is B. This is center. The distance between them is what? 2 centimeters. We have to calculate at a point P. They have not mentioned from where, whether it is along axial line or equatorial line. So we should calculate potential across axial line as well as equatorial line. See, this is two equal and opposite charges separated by small distance. So it considers as what? Potential due to a dipole. From this, the distance is what? 20 centimeters. So distance R is equals to 20 into 10 raised to minus 2, nothing but 2 into 10 raised to minus 1 meter. Charge on each magnitude of charge how much? 1 into 10 raised to minus 9. Distance 2A is equals to 2 centimeters. Now potential due to a dipole along axial line. V axial equals to what? 1 by 4 pi epsilon naught P cos theta by r square. For axial line, theta is equals to 0. Substituting the values. V axial is equals to 9 into 10 raised to 9. P can be written as Q into 2A. What is Q? 1 into 10 raised to minus 9 into 2 into 10 raised to minus 2. Distance square. 4 into 10 raised to minus 2. Plus 9 minus 9 cancel. Minus 2 cancel. What do you get? 2 by 4. 4.5 volts. Next. Same way. Potential along equatorial line. Potential along equatorial line is equals to what? 0. Because two equal and opposite charges separated by distance. Theta is equals to 90. So this is the way of calculating potential due to different charges along axial line and equatorial line. Next one. So this question is important for 2 marks or 3 marks. See that if potential varies as V is equals to 4x square, calculate electric field at 1, 0 and 2. So what the given? Given potential V equals to 4x square. Now what is the relation between electric field and potential? Let us write the relation. We know that electric field is equals to minus dV by dr. As you observe here, the potential lies only along x-axis. So let us take that E is equals to, generally what we can write, minus dV by dx into I cap minus dV by dy into j cap minus dV by dz into k cap. So here all x components are 0. What we can write, E is equals to minus dou by dou x of 4x square into I cap minus dou by dou y of 4x square into j cap minus dou by dou z of 4x square into k cap. Here there is no y component, here also y z component, so these two terms becomes 0. Now electric field lies only along x axis minus d by dx of 4x square. D by dx of 4x square is what? 2x. So minus 8x I cap at 1, 0, 2. E is equals to minus 8 into 1 into I cap, that is equals to what? Minus 8 I cap. So if potential varies along x-axis in a plane is V is equals to 4x square, then what is its electric field at 1, 0, 2? So the given potential as V is equals to 4x square, and we know that the relation between electric field and potential E is equals to minus dV by dr, extending it in 3 coordinates, minus dV by dx into I cap, minus dV by dy into j cap, minus dV by z into k cap. So differentiation of 4x square along x-axis is what? Minus 8x I cap. They given some point. At this point we have to calculate the electric field. So what is that? 1, 0, 2. So substituting the value of x 1, then we get minus 8 cap. So electric field varies along negative x-axis as minus 8. The magnitude is 8 and in negative x-axis.